Okay, this is a machine that we call the transforming generator, and the reason for that is because this machine actually incorporates two separate technologies in one embodiment. It's both a generator and a transformer. And in order to demonstrate that and then explain why it's useful, I'm going to run this device for you and produce an interesting little experiment here. The main reason I built it was actually to study the difference between EMF and voltage. Now I know that most people think that they're the same, but they're not. An EMF is called electromotive force. That's the force that pushes current. And the current passing through an impedance, which could be a resistor, a capacitor, or inductor, or whatever, actually the pressure of the charge that cannot flow through the impedance simultaneously is what develops the phenomenon that we call voltage. So it's okay to use them interchangeably for certain calculations when you understand what you're doing, like in the application of Kirchhoff's laws for studying mesh and node equations, but there are times when you really have to keep them segregated. And so I built this particular machine to allow me to concentrate on the force aspect of this separately from the voltage aspect. Now, a lot of the results of that are proprietary. I'm not going to go into the details, but I will show you a couple of interesting features, and we'll use that to further the explanation of the machine. First of all, there are two sets of windings in this machine. One set is brought out on this pair of lines, and the other set is brought out on this pair of wires. Now these two conductors go directly to this 300-watt bulb. The ones from this side do not come directly to this bulb. They go through this little selector switch, this little knife switch that's down here. One side of that knife switch has a copper bar across it, which essentially constitutes a short circuit. The other side will allow the connection to be made to this bulb. It's important to understand that ahead of time so that you can grasp the significance of the demonstration. So with that, I'm going to bring this guy up to speed. I'll be using a RPM meter to set the high end of the RPM so that we don't blow any fuses. Okay, we're at about 2200 RPM, and that's going to be sufficient to demonstrate what I have to show you. So the next thing we're going to do is turn up the field on the generator so that it starts producing a voltage. You'll notice a glow will appear in that lamp over there when we reach a certain setting. There it's starting to glow now. I'm going to take this meter and we're going to do a couple of voltage measurements just so I can make a point. First I'm going to turn the lamp off. So now there's no load on that particular winding. We have 59.2 volts, almost 60 volts. Now if I turn this lamp back on, when we get the glow again, now that we have the glow, we'll take the voltage measurement and you'll see that we only have 15.7 volts actually appearing across that lamp. 15.6, okay? So most people would say, well, we just had 60 volts there, where did the other 45 go? it's actually sitting inside the generator across the windings in a phenomenon known as inductive reactance. It's actually consuming that other amount of voltage so that it cannot reach the lamp. Now, normally in a standard generator, the way they get around that is they have a whole series of windings and they connect them all together. This machine only has 2 windings, and I'm going to be able to put the full production voltage into that lamp just by making a slight change in the circuitry. You notice all the controls are underneath. I'm not going to touch a thing under there. So the setting on the field is going to remain absolutely the same. But I am going to close this little switch, as I mentioned to you before, and we're going to go first to the short circuit, which is a copper bar that's placed across the output of this switch. That's going to cause a current to flow in this winding, which will change the magnetic coupling coefficients between this coil and that coil, and it's going to release the full potential of that coil into the lamp. See that? Now the interesting thing is that this side of the coil to that side appears as a capacitor, and that's the reason it can do that. It actually resonates that winding, which means it gets rid of all of its resistance to the total amount of flow of electricity. But if I put this to this side, you notice now both lamps come on, and that's because this side opens that side of the generator, and this side opens this side of the generator, allowing the total amount of power that's being created to flow into the lamps. Now, there's some very special reasons for investigating this kind of thing, most of which have to do with the way I've designed a lot of the equipment in this room. But I wanted to demonstrate that in particular because it's a very fundamental concept, and it will appear in every single machine that you're going to see throughout the course of this demonstration.